Okay, so we have analyzed the structure of the mitochondria. Beautiful concept. Now let's get into a very interesting topic, something called as the ETS, the electron transport system. What happens in ETS? At different stages of glycolysis, acetylation, Krebs cycle, oxidation took place, and 2H plus was given. NAD combines with the 2H plus to form NADH plus H plus, and we remember each will undergo electron transport system to form 3 molecules of ATP. How does that exactly take place? So सबसे पहले let us find out how many NADH plus plus and FADH plus are formed. If you remember, glycolysis में 2 NADH plus H plus are formed. In which step, if you remember, 3-phosphoglycer aldehyde forming 1,3 diphosphoglyceric acid में we have 2 NADH plus H plus. So कौन से step पे sir? Here we have glycolysis, 3-phosphoglycer aldehyde forming 1,3 diphosphoglyceric acid. We have 2 molecules of 2 NADH plus H plus. Then during acetylation, we have pyruvic acid forming acetyl coenzyme A. So 2 more NAD form 2 more NADH plus H plus. And then during Krebs cycle, in the conversion of citric acid to oxalosuccinic acid, 2 NADs give 2 NADH plus H plus, and then conversion of alpha ketoglutaric acid to succinyl coenzyme A. Again, we have 2 NADH plus H plus. And last step, we have malic acid forming oxaloacetic acid. We have again 2 NADH plus H plus forming H plus. So sir, कितनी बार हुआ? Glycolysis में once in glycolysis. So one time in glycolysis, once during acetylation, once during acetylation, and once, twice, and thrice during Krebs cycle. Once during glycolysis, and once during acetylation, and twice during, or rather 4 times during the Krebs cycle, multiplied by 2 molecules, because 1,3 diphosphoglyceric acid, rather 3-phosphoglyceraldehyde, became 2 molecules of 1,3 diphosphoglyceric acid. So how many NADH2s are formed? 2 NADH. That is 2 NADH plus H plus. Similarly, pyruvic acid के 2 molecules है. So here we have 2 NADH plus sir. So again we have 2 molecules. Similarly, in Krebs cycle, we have 2 NADH plus and 2. And यहाँ पर भी 2. यहाँ पर भी 2. So total, how many NADH2s are formed? Glycolysis say 2. Acetylation say 2. That is 2 plus 2 become 4. Krebs cycle में 2 plus 2 plus 2. So a total of 2 plus 2 plus 2 plus 2 plus 2 a total of 10 NADH plus plus H plus. 10 NADH plus H plus. And we have 2 FADH, 2 FADH2s. Here also is 2 molecules, so 2 FADH2s. So we have a total of 10 NADH plus 10 NADH plus, I'm just writing it again, 10 NADH plus H plus H plus and 2 FADH plus 2 all undergoing ETS, means a total of 12 ETSs will take place. Total how many ETS will take place? 12 ETSs will take place. 12 times ETS will take place. Golden words. एक NADH2 से कितना ATP बनेगा? एक NADH2 से 3 ATP. So 10 NADH2s will give you a total of 30 ATPs. And one FADH2 gives 4. So 2 FADH2s will give you 4 ATPs. And a total of 30 plus 4, a total of 34 ATPs are formed, and that is the total production. How many ATPs we are getting? A total of 34 ATPs are getting produced. 30 plus 4, 34 ATPs are getting produced. 30 plus 4, a total of 34 ATPs are produced by ETS. Electron transport system से आपको total 34 ATPs मिलते हैं. Beautiful process. Let's see how this happens. इसे ध्यान से analyze करना. At various steps, a reduced substrate becomes oxidized. Say 1,3 diphosphoglyceric acid, 3-phosphoglyceraldehyde undergoes oxidation to form 1,3 diphosphoglyceric acid, or pyruvic acid undergoes oxidation to form acetyl, or oxalosuccinic acid undergoes oxidation to form rather isocitric acid undergoes oxidation to form oxalosuccinic acid, or alpha ketoglutaric acid undergoes oxidation to form succinyl coenzyme A, or malic acid undergoes oxidation to form oxaloacetic acid. तो ऐसे टोटल कितने बार NADH2 बनेंगे? NAD, how many times hydrogen will be given, sir? 10 times. Who is the first hydrogen acceptor? NAD will accept the hydrogen and get reduced to form NADH2. Giving away hydrogen is called oxidation. Accepting hydrogen is called reduction. So once again, the substrate by giving away hydrogen undergoes oxidation, whereas NAD by accepting the hydrogen undergoes reduction to form NADH plus plus H plus. Yeah. So again I'm writing, reduced substrate by giving away hydrogen undergoes oxidation, and NAD by accepting the hydrogen gets converted into NADH plus H plus. So what has substrate become? Substrate has become oxidized by giving away hydrogen. And what has NAD become? NAD has become reduced by accepting the hydrogen. And what is such a reaction where there is simultaneous oxidation and simultaneous reduction called as, we all have heard of it in school, that is called as a redox reaction. इसे क्या कहते हैं? Redox reaction. So this is a redox reaction in which there is oxidation, and simultaneously by accepting hydrogen there is reduction. And what is that collectively called as a redox reaction? That is called as a redox reaction. So we are having oxidation by giving away hydrogen, and by accepting reduction, that is called as a redox reaction. So reduced substrate undergoes oxidation. Reduced substrate undergoes oxidation, and NAD by accepting the hydrogen gets reduced to become NADH2. So NAD gets reduced to become NADH2, and that is called as a redox reaction. NADH2 again gives away hydrogen. NADH2 gives away hydrogen and gets oxidized back to NAD. What is giving away hydrogen called? Oxidation. So NADH2 by giving away hydrogen gets oxidized back to NAD. Oxidized back to NAD. And now the hydrogen is accepted by FMN. FMN is called as flavin mononucleotide. What is FMN called as, beta? Flavin mononucleotide. FMN is called as flavin mononucleotide. What is FMN called as? Flavin mononucleotide. FMN. And flavin mononucleotide accepts the hydrogen and gets reduced to become FMNH2. Flavin mononucleotide accepts the hydrogen and gets reduced to become FMNH2. FMNH2 once again gives away the hydrogen and gets oxidized back to FMN. तो अगर ध्यान से continuously oxidation reduction चल रहा है. पहले substrate underwent oxidation and became reduced to or became oxidized. Then the hydrogen was accepted by NAD. And hydrogen was accepted by NAD, and NAD got reduced to become NADH2. Then NADH2 gave away the hydrogen and got oxidized. NAD gave away the hydrogen and NADH2, gave away the hydrogen and got oxidized back to NAD. And that hydrogen is accepted by FMN, and flavin mononucleotide gets reduced to form FMNH2. So continuously क्या हो रहा है? Giving away hydrogen is called as oxidation. Accepting hydrogen is called as reduction. Giving away hydrogen is called as oxidation. Accepting the hydrogen is called as reduction. And oxidation reduction, in other words, redox reaction chal raha hai. Now FMNH2 gives away the hydrogen and gets oxidized back to FMN. It gets oxidized back to FMN. and this FMN is now formed, and the two hydrogens are accepted by coenzyme Q, and coenzyme Q on accepting the hydrogen get reduced to become coenzyme QH2. Coenzyme QH2. And coenzyme Q is also called as ubiquinone. And when it gets reduced to coenzyme QH2, it is called ubiquinol. So what is coenzyme Q called as? Ubiquinone. And what is coenzyme QH2 called? Coenzyme Q H2 is called as ubiquinol. So ubiquinone becomes ubiquinol. Ubiquinone becomes ubiquinol. In other words, what has happened? Coenzyme QH2 has got reduced to become coenzyme QH2. Coenzyme QH2 also gives away hydrogen. It will also give away hydrogen. और हमेशा याद रखना, हाइड्रोजन जब भी जाता है एनर्जी लेके जाता है. हाइड्रोजन जब भी जाता है एनर्जी लेके जाता है. सो एट डिफरेंट स्टेप्स हाइड्रोजन गया, एनर्जी लेके गया. कौन कौन से स्टेप्स में हाइड्रोजन गया? हाइड्रोजन फर्स्ट वेंट फ्रॉम अ सबस्ट्रेट, 5 of them: 3-phosphoglyceraldehyde, pyruvic acid, isocitric acid, alpha ketoglutaric acid and malic acid. तो ये 5 सबस्ट्रेट थे, उसमें से हाइड्रोजन चला गया. Who was the first acceptor of hydrogen? NAD to become NADH2. From NADH2, where did it go? FMN to become FMNH2. From FMN, where did it go? Coenzyme Q to become coenzyme QH2. तो 4 बार हाइड्रोजन पास हुआ है. From substrate to NAD, from NAD to FMN, from FMN to coenzyme Q. एंड जब कोएंजाइम क्यू से हाइड्रोजन पास होता है, दिस हाइड्रोजन इज रिच इन एनर्जी. एंड नाउ ये चारों चार हाइड्रोजन एक्सेप्टर थे. चारों चार हाइड्रोजन एक्सेप्टर थे. विच वर द हाइड्रोजन एक्सेप्टर? रिड्यूस सबस्ट्रेट, NAD, FMN, coenzyme Q were hydrogen acceptor. Now hydrogen 2H splits to form 2 electrons and 2 protons. And protons remain in the matrix. Protons remain in the matrix. Krebs cycle कहाँ हुई? Matrix में. तो transfer of substrate to NAD, then to FMN, then to coenzyme Q, then 2 hydrogen split to form proton and electron. ये पूरा प्रोसेस कहाँ हुआ? मैट्रिक्स में. And ध्यान से, the 2 hydrogens were rich in एनर्जी। और ये दो हाइड्रोजन जब स्प्लिट होते हैं टू फॉर्म प्रोटॉन एंड इलेक्ट्रॉन, all the energy goes into the electron. So who is energy rich? 2H has rich in energy. 2H is rich in energy. It splits to form electron and proton. And who is rich in energy? The energy is there in electron. So proton is not with energy. Energy goes into electron. And proton remain in the matrix. Proton remain in the matrix. It is the electron which will pass into the inner mitochondrial membrane. Electron will pass into the inner mitochondrial membrane, which has a series of electron acceptors. We will come to it. You may remember right now, cytochrome B, cytochrome C1, cytochrome C, cytochrome A, cytochrome A3, and finally oxygen. Where are all these electron acceptors found? On the inner membrane. So if we see in the diagram carefully, where is Krebs cycle taking place? Krebs cycle takes place inside the matrix, and it gives away hydrogen. Who's the acceptor of hydrogen? NAD. NAD. So say Krebs cycle in the matrix, and then where is hydrogen taken by? NAD. From NAD, where does it go next to? FMN. From FMN, where does it go to? Coenzyme Q. Coenzyme Q. From coenzyme Q, where does it go? It forms proton and electron. Where does Krebs cycle, NAD, FMN, coenzyme Q, proton, everything remain? They remain inside the matrix. So matrix में वो सब रह जाएगा. हाँ, what did two hydrogen split to become? Two hydrogen split to become proton and electron. Two hydrogen split to become proton and electron. 2H split to become proton and electron, of which protons remain in the matrix, but electrons pass from the matrix to the inner mitochondrial membrane. Electrons pass into the, तो ये प्रोटॉन है, प्रोटॉन किधर रह जाएगा? मैट्रिक्स के अंदर. और इलेक्ट्रॉन्स कहां पास होंगे? इनटू द इनर माइटोकॉन्ड्रियल मेम्ब्रेन, एंड इनर माइटोकॉन्ड्रियल मेम्ब्रेन हैज इन इट इलेक्ट्रॉन ट्रांसपोर्ट सिस्टम. Electron transport system, which consists of some names I said: cytochrome B, cytochrome C1, cytochrome C, cytochrome A, cytochrome A3. So once again, cytochrome B, C1, C, A, A3. Where are all these electron acceptors present? all electron acceptors are present on the inner mitochondrial membrane. So, where is Krebs cycle taking place? Krebs cycle takes place inside the matrix. यहाँ पर होती है Krebs cycle. Where does transfer to NAD, FMN, coenzyme Q take place in the matrix? What does coenzyme Q give out? 2 hydrogen. 2 hydrogen. Where in the matrix? So Krebs cycle is in the matrix and NAD, FMN, coenzyme Q, 2 hydrogen are in the matrix. What happens to 2 hydrogen? Splits to form proton and electron. Where will protons remain? Protons remain in the matrix. Protons remain in the matrix. Where will 2 electrons transfer? The 2 electrons will go towards the inner mitochondrial membrane where they will pass through the electron transport system consisting of cytochrome B, cytochrome C1, cytochrome C, cytochrome A, cytochrome A3 and undergo the electron transport system. Let's see what this is, the ETS.